So good morning. Welcome to the lecture number 5 on numericals on signal transformation. In the previous lectures, we have discussed about the different signal transformations. We studied time shifting, we studied time reversal and time scaling in detail. Also, we solved numericals on individual of these. Right? We understood time shifting is nothing but that causes shifting of the signal in time domain. Either the signal shifts to the left or shifts to the right. In time reversal, the signal gets folded. We understood that the signal is folded along y-axis, right? So we get a mirror image of the signal, right? In other words, the signal on the left hand side appears on the right. The signal on the right hand side appears on the left hand side. So we called it as the reflection of the signal. And the third signal transformation we studied was time scaling. In time scaling, we saw that we scale the time that results into either compression of the signal or expansion of the signal, right? So all these three we have studied in the last two lectures. So I want to devote this particular lecture to solve numericals on it, right? So we'll be solving numericals based on this. So let us first of all quickly revise the rules that we have followed. So whenever we solve numericals on signal transformation, what is essential? It is essential in step number 1 to identify what are the different signal operations present in the given problem. Identify the different operations, whether there is time shifting, time reversal, time scaling, what are the different operations hidden in the given problem. Once you identify the different operations, then in step number 2, we give highest priority to time shifting operations. So if in the identified signal operations, if time shifting operation is present, it has to be performed first, right? We perform time shifting operation first. After which, if there is time reversal or scaling or both operations, then we can perform either of them. There is no priority to time reversal and scaling operations. You can perform any one of singularity functions that we have already done in lecture number 1 and 2. So what are the singularity functions of CT signal? So unit step signal. So whenever you see UT, you should understand that it is describing which type of signal? Unit steps. Friends, these are basic signals, right? Their structure, their definition remains fixed. So whenever UT is observed, you should understand that it's a unit step signal which is defined in this way. It is completely a right-handed signal whose magnitude is 1 and remains 1 up to infinity. This is unit step signal we had discussed. Unit impulse is denoted as delta t, right? So delta t is impulse which exists at 0 with a magnitude 1. Everywhere else it is 0. This is unit impulse. Whereas ramp signal is again a standard signal, right? And as the name suggests, as the magnitude increases, the ramp signal increases. So at 0 it is 0, at 1 the magnitude is 1, at 2 the magnitude is 2, at 3 the magnitude is 3, and so on, and ramp signal goes up to infinity. So we have unit step signal which remains 1, the magnitude remains 1 but tends to infinity. Then with respect to time, the signal goes to infinity. Whereas in ramp signal goes to infinity. As the time increases, the magnitude goes on increasing linearly. So these are the standard signals which you should be aware of. Similarly, these standard signals exist in DT signals also, right? So we have unit step signal, we denote it as U of n, right? So again, it is the samples in DT unit step signal are all 1. They are all 1. These dot indicates that the samples are going to infinity. So all these samples, it's again a right-handed signal because there is no sample on the left-hand side. We call unit step signal as a right-handed signal, right? So there are infinite samples, but all the samples have magnitude 1. This is standard signal. Impulse delta n. We, instead of delta t in units in dt signal, we call it as delta n. Again, it's an impulse. It remains 1 at 0. Everywhere else it is 0. Whereas a ramp signal, right, it is also again linearly increasing. All the samples have magnitude increasing with respect to time. So at 0 it is 0, at 1 it is 1, at 2 it is 2, at 3 it is 3, and so on. And you could see here the dots here indicate that the sample is tending to infinity. So these basic samples should be very, very clear and defined very well before you solve problems on signal transformation. So I have revised it for you once again so that you can apply it correctly when you are solving numericals. Now let us understand the first numerical, right? So few numericals I have solved here and few we will be solving together, right? So this is the first problem. What is being asked to you here? You have been asked to sketch the signal yt, which is difference of u of t minus 1 minus u of t minus 5. So as just discussed, what is UT signal? UT signal is unit step signal. Right, so when I do u of t minus 1, what is being done here? Can I say we are shifting unit step signal by 1 unit? U of t minus 5 indicates that the signal is shifted by, unit step signal is shifted by 5 units. So, in order to sketch your signal yt, what you need to do? You need to first obtain y of t, u of t minus 1. You need to obtain u of t minus 5 and then take their difference. The resultant signal becomes your yt. So, let us do it step by step. So, let us first obtain UT signal, right? So, unit step signal. So, unit step signal is a standard signal. We know it is 1, right? For all the time instants, right? Magnitude is 1. And on the left hand side, the signal is entirely 0. This is our standard unit step signal. What I need to do first? I need to obtain U of t minus 1. Now, t minus 1 means signal is time shifted. Signal is delayed. Minus 1 indicates signal is delayed by how many units? By 1 unit. So, you are delaying this particular signal, that is shifting this particular signal with respect to time by 1 unit. Right? So, this signal is shifted, delayed, and how the delayed signal is the signal is delayed to the right hand side by 1 unit. Right? So, entire signal when shifted by 1 unit this is the way the signal looks. So, instead of starting at 0, the signal starts at 1. Right? So, up to 1 the signal is 0. From 1 the signal remains 1 with a magnitude 1 for all the remaining time instant. So, this is the shifted unit step signal. Right? So, this is what I have obtained here now. Now, the rest part of the problem says obtain u of t minus 5. So, what I need to do now is shift unit step signal by 5 units. Right? So, I have to shift this signal. Again, it is delayed. Signal shifts to the right by 5 units. Right? So, how does the delayed signal look? You could see here the same unit step signal is delayed now by 5 units, right? So, instead of starting at 0, signal gets delayed, starts at 5, remains with a magnitude 1 for all the remaining time instants. For all the time instant, it remains 1. So, up to infinity, it is 1, right? So, we have not terminated the signal. It means that signal goes to infinity. So, we have obtained u of t minus 1, u of t minus 5. What is the intention is to do the subtraction of these two signals in order to obtain yt. So, let us do the subtraction now. So, we have to subtract u of t minus 5 from u of t minus 1. Right? So, what we observe? We observe that both the signals are 0 up to 1. So, up to 1, the signal remains 0. The subtracted signal remains 0. Now, what happens at 1? At 1, u of t minus 1 exists, right? But u of t minus 5 is still 0. So, subtract means we are subtracting the magnitudes. So, 1 minus 0 means the magnitude remains 1. So, up to, can I say up to 5? the magnitude is 1 because the signal is entirely 0. Right? So when I start to sketch the signal, what do I observe? That up to 1, the subtracted signal is 0. From 1, the subtracted signal takes a magnitude 1. Right? So 1 minus 0, 1 minus 0. Right? So magnitude remains 1. Now what does it happen at 5? At 5, u of t minus 1 is 1. But what is the magnitude here? Now it is no more 0. It has taken a finite magnitude of 1. So can I say that both the signals are having a magnitude 1 at 5? So when you do the subtraction, 1 minus 1, it becomes 0. So can I say at time instant 5, these subtracted signals take a value of 0. What happens at 6? At this time instant 6, we know that this signal is infinite. So at 6, it is 1. At 6, this is also 1. 1 minus 1 is 0. Similarly, at 7, 1 minus 1 is 0. Can I say that after 5, as both the signals are having a magnitude 1, the subtracted signal will result in 0. Right? So if we sketch the resultant signal, the resultant subtracted signal, this is how the YT signal is. Right? So up to 1, both the signals were 0. From 1, the magnitude remains 1 up to 5. At 5, both the signals become 1 and hence the resultant magnitude becomes 0, after which it remains 0 because both the signals are remaining at 1. Right? Both the signals are at 1 and hence 1 minus 1 signal is continuously 0. So this is how your YT signal is. So if you do step by step proper subtraction, you can correctly get your resultant YT signal. So this is what was asked to us, sketch the YT signal, and this is the sketch of the given problem. Now with YT signal, you have been expected to do certain operations on it. So as just discussed previously, what we have to do whenever we solve problems, identify the signal operations. Right? So the first very step is identify what are the expected operations in the given problem. Right? So how do we identify it? So first identify whether there is shifting. Yes, there is shifting, right? So there is t minus 1 involved here. Right? So there is a shifting involved here. So how is the shifting? How did you identify this t, and there is a minus 1 here. So there is t minus 1 shifting hidden here. Right? What is the next operation we can identify? That is 2t. 80, if you remember, if you have watched the video, you can identify the scaling operation y of 80. What is my scaling factor? Scaling factor is 2. So if you multiply t by any constant, you are doing a time scaling operation. So you are multiplying t by 2 here. So there is a time scaling operation. And if there is a minus sign associated with t, then there is one more operation, which is reversal. So this is the way you identify the various signal transformations that you need to perform. Right? So first we'll perform shifting. As per the step number 2, we have to perform shifting. So what is the shifted signal here? This 2 is for scaling. This minus which is with respect to t is for reversal. Right? So definitely this minus 1 is for shifting. So how is your shifting? T minus 1 is the shifting operation involved here. So we have to shift the YT signal by 1 unit to the right. It's a delayed signal. So delayed signals get shifted to the right. Right? So this signal, when shifted to the right, will start at. So this particular starting instant is 1. Shifted by 1 unit, it starts at 2. The ending instant is 5. Shifted by 1 unit to the right, it ends at 6. So once you understand the starting and the ending instant, what you need to do is simply draw your signal in the identified time instants. Right? So this becomes my shifted signal. So we have performed our step number 2, which is first operation which we identified, which was shifting. Now, as mentioned in step number 3, we can perform either reversal or scaling. There is no priority to it. Right? So let us perform scaling. So what is the scaling here? Scaling is by a factor of 2. Right? The scaling factor is greater than 1. So definitely it is nothing but resulting into time compressed signal. Right? So we are compressing the signal. Right? So in the next step we are doing time scaling, in which we will compress the signal obtained in the previous step. So we are going to compress this. What is the compressing factor? The compressing factor is 2. Right, so when I do this, what is the signal I'll be obtaining? I'll be obtaining y of 2t minus 1. So I have appended this 2 to the time instant t, right, through which I'll now be performing scaling. So my resultant signal is named as y of 2t minus 1. Right, so let us do scaling. So as discussed previously, compression means the signal time base of the signal should be divided by the scaling factor. So scaling factor is 2. So let's start dividing. So the first time instant 2, starting instant is 2 divided by 2. So the starting new scaled time instant is at 1. And where is the ending instant? So 6 divided by 2, ending instant is 3. So we now understood that when we do the scaling, the starting instant is 1, the ending instant is 3. So simply draw your signal in the new time instance 1 to 3. So when you draw it, you observe that what you have obtained is the compressed signal. So scaling has resulted into compression of the signal here. Right? So this is your step number 2. Now what remains is the next step. Now we have to obtain the reversal. Now we have to append a minus sign to t. Right? This minus sign is what we have to append to t. Now how do we do that minus sign here? By doing reversal. Minus indicates you are doing reversal. So now we have to do reversal of the time scale signal. So in step number 4, we are going to perform reversal. So when I do reversal, what is the new name of the signal? Append the minus sign to t. Right? So the name of the signal is y of minus 2t minus 1. So this is the signal I will be obtaining when I will do reversal of the time scale signal. Right? So reversal means reflect the signal on the other side. Right? So plus 1 when reflected on the other side should appear at minus 1, plus 3 should appear at minus 3. So now you understood that signal is going to appear from minus 1 to minus 3. So minus 1 to minus 3, magnitude is not changed, magnitude remains 1. Right? So you have done a reflection of the signal. Simply you are doing the mirror image of this signal on the other side. Right? So how to simply do that? You negate your time instants. So whatever is at plus 1, you sketch it at minus 1. Whatever is at plus 3, sketch it at minus 3, keeping the same magnitude. So whatever you get is your time reverse signal. And finally, this was what was the given problem task. Right? Y of minus 2t minus 1 was what was asked to us to finally obtain, and this is the resultant sketch of the signal. So systematically, if you follow the rules, if you follow the scaling and shifting operations carefully, there would not be any mistake in plotting or doing the signal transformations. Now let us do one more problem. This time we are doing a DT signal, right? So what is given to you? Understand the given problem first. So you have been given two signals, friends, Xn and Yn. Right? So Xn has 4 samples, Yn has a 4 samples. In Xn, there is no arrow here, whereas in Yn, there is an arrow shown in the problem. Right? We have discussed it, what is the meaning of it. And with these two signals, you have been asked to find sum of the two signals multiplied to shifted unit step signal. Right? This added signal is multiplied to unit step signal. Right? So let us do it one by one. So given the problem, how would we proceed to solve the problem? So step number 1 is sketch the two signals independently. So we'll sketch Xn first and then we'll sketch Yn. So let us understand xn. So there is no arrow. It indicates that the first sample should be appearing at 0th time instant. Right? So at 0, the magnitude is 1. Then the next time instant is 1. At 1, the next sample appears. So the next sample appears at 1, whose magnitude is 4. At next time instant 2, the third sample appears, whose magnitude is -2. At the next time instant 3, the last sample appears, whose magnitude is 3. So this way we have sketched the signal xn. Now let us sketch yn. With the given information, we will sketch yn. Right. What do we understand here? There is an arrow. There is an arrow in bottom at the bottom of one of the samples. Right. What that arrow indicates? It indicates that wherever there is an arrow is the 0th instant of the sample. Right. So at the arrow, right, is the 0th position of the sample. So this particular sample should appear at 0. At 0, the magnitude is -1. So definitely if this sample is appearing at 0, the next sample should be, if it is on the left hand side, that sample should appear at -1. This sample will appear at -2 and this sample appears at -3, right? So all these plotted together shows us that it's a complete left-handed signal. Right, so at 0, the sample is -1. At -1, the sample is having a magnitude +1. At -2, the magnitude is 0. There's nothing at -2. Whereas -3, the last sample of magnitude 2 is shown to you here. Right, so this is what your yn signal is, a completely left-handed signal. Right, so now we have done plotting of xn, we have done plotting of yn. Let us proceed to what we have to actually find. We have to find first, initially, is the sum of these two signals. So let us do the sum of these two signals. So we have to add xn and yn. Right, so here you could see the plot is shown. Xn plus yn is what we intend to do. How to do the addition? Remember, the addition is sample by sample basis. It means that here the sample is at -3. So sample at -3 should be added with the sample at -3 of the signal. So there is no signal here. It means that the magnitude is 0. So 2 plus 0 means 2. At -3, the sample remains at 2 because there is no sample in xn. No sample means the magnitude is 0. So 2 plus 0, it means that the magnitude remains 2. At -3, the sample has the magnitude 2. At -2, there is a 0 here, there is also a 0 here. So resultant addition, -2 has a magnitude 0. At -1, there is a sample of 1. At -1, there is no sample here, so magnitude remains 1. So at -1, the magnitude remains 1. What happens at 0? If you see here at 0, both the signals have samples. So this time we have to add their magnitudes. So 0. At this xn signal, the magnitude is 1. For this yn signal, the magnitude is -1. So add the magnitudes. So 1 minus 1, 0. So at yn, the resultant sample has a magnitude 0. So there is no sample here at 0. Right? Now add the next remaining samples. At 1. At 1, the magnitude here is 4. At 1, there is no signal here. Right? So magnitude remains the same. So at 1, the magnitude remains 4. Similarly at 2, as there is no signal here, then this magnitude remains unchanged. So at 2, the magnitude is -2. At 3, since there is no magnitude here, so 3 plus 0, the magnitude remains 3. Right? No samples after which. So this is your resultant addition of the signal xn plus yn. So we have added the two signals. So we have finished part of the problem now. Now we have to multiply this added signal to unit step signal. But the unit step signal is having certain operations on it. So let us identify the operations. What are the operations? So clearly there are two operations involved here. One, is n minus 1. So there is shifting. And secondly, there is a minus sign associated with n, which indicates that there is a reversal. Right? So there are two operations done on unit step signal. Right? So let us do the first. What is having the highest priority? The shifting. So we have to shift the unit step signal. So we'll first of all draw the standard unit step signal. So our standard unit step signal is infinite samples, all of magnitudes 1. Since we can't draw infinite samples, we'll be always showing these dots. So these dots indicate that the samples are tending to infinity. All the samples have magnitude 1. This is our standard signal. Now we will shift. Now we'll do shifting operation of this. So we'll shift the signal by 1 unit. So this signal delayed by 1 unit shifts to the right hand side. So starts at 1, right? Instead of 0, when shifted, it starts at 1 and goes to infinity. So samples, the magnitude remains the same. So it goes to infinity. Now what are we are expected to do? We have to multiply. We obtain this signal u of, oh I'm so sorry. We have done just shifting of the signal u of n minus 1. Still what we need to do? We have to append a minus sign to this. Minus n means we have to do one more operation, which is nothing but reversal. So now we'll do reversal of the signal. So in the next step, what we have done? This particular shifted unit step signal is reversed. Right? So reverse means we append a minus sign. So we call the signal now as u of minus n minus 1. So we are going to do reversal. Reversal means we reflect the signal. So simply whatever is there on one side should appear on the other side, and vice versa. The other side appears on the previous side. Right? So sample at plus 1 appears at minus 1. Sample at plus 2 appears at minus 2, and so on. Right? So this time in the earlier, before reflection, the signal was going to infinity on the positive side. When we have reversed the signal is going to infinity on the negative side. Right? So entire samples are reversed. There is nothing on the right, on the left hand side in the original signal. There is nothing on the right hand side in the time reverse signal. Right? So this is our time reverse signal. Now what we intend to do is perform the multiplication. So the last step is multiply the two signals. Which two signals are we intended to multiply? These two. So we have to multiply these two signals, right? Multiply xn plus yn with u of n minus 1. These two signals we are going to multiply, right? So multiplication is again sample to sample basis. It means that sample at 0 should be multiplied with sample of 0 of the other signal. Sample of at 1 should be multiplied with sample at 1 of the other signal. Right? So you cannot multiply different time instants. Similar is true for addition, similar is true for subtraction. So add the samples at the same time instance. Multiply the signals of the same time instance. Right? So let us start with minus 3, as this signal is 0 previous to this, right? 0 into anything would be 0 because these samples are tending to infinity, right? So all these samples are present up to minus infinity, but this signal is 0 up to minus 3. So 0 into anything would be 0. So where does the multiplication exist? Multiplication start to exist from minus 3. So multiply these time instants. Sample at minus 3 is multiplied with sample at minus 3. Right? What is the magnitude here? You multiply the magnitudes. What is the magnitude at minus 3? It is 2. What is the magnitude at minus 3 here? It is 1. So 2 into 1 is 2. So at minus 3 we get a magnitude as 2. We draw the sample of magnitude 2. Next multiplication. Now we will multiply the time instant minus 2 with the time instant minus 2 of the other signal. What is the magnitude here? It is 0. What is the magnitude here? It is 1. So 0 into 1 becomes 0. So what is the resultant magnitude at minus 2? It is 0. The next time instant minus 1 is multiplied with the next time instant minus 1. The magnitudes are multiplied. What is the magnitude? It is 1 here. It is also 1 here. So 1 into 1 is 1. So resultant at minus 1 we draw a sample of magnitude 1. At 0, this is 0, this signal is also 0, right? And therefore resultant signal at 0 is 0. Now what we observe, that there are no samples in the right hand side of u of minus n minus 1. So there are no samples here. No sample means all the samples have a magnitude 0. So if you multiply such a signal with a signal which has samples, so definitely 0 into those will be 0. Right? So at 1 there is no signal here. So 0 into 4 is going to be 0. At plus 2 there is no sample here. So 0 into minus 2 would be 0. At 3 there is no sample here. 0 into 3 is going to be 0. And so on. So that's why there is no sample on the right hand side of the resultant product. So finally what is the answer? In the answer we see only 2 samples. Right? At minus 3 and at minus 1. So this is what was the given problem task. That we obtained, we added xn plus yn and then multiplied it with the shifted and reverse unit step signal. This is the resultant answer. Let's move to the next question. Now here, the next question is, you have been given a signal Sn and you have been asked to first of all obtain S of 2 plus 3n and multiply this particular signal with delta n minus 1. This is the given task. Now here we will be doing the problem together. Let us do this particular problem together. Right. So let us start the problem by sketching your given input signal. Right. So let us start by sketching the signal Sn. So as you see, there is no arrow here. It means that the sample starts at which time instant? Definitely at 0. Right. So the first sample appears at 0. So let us start to sketch the signal. So I have drawn the base here and we'll go on putting the magnitude. So at 0, what is the magnitude of the signal? It is 1. Right. So at 0, the magnitude is 1. At 1, magnitude should be 3. So at 1, the magnitude is 3. At 2, the magnitude is minus 1. Right. At 3, it is 0. Right. At 4, the magnitude should be 3. Right. The next time instant, 5, it is minus 2. The magnitude is minus 2. At 6, the magnitude is minus 3. Whereas at 7, it is 4. Right. So this way we have sketched the given problem. Here you can even put the magnitudes of your signal. Right. Let us put the magnitude. So the magnitude of this signal is 1. Right. The first sample has a magnitude 1. Let us put magnitudes to each of the sample. Right. Then it is 3. Then it is minus 1. Then it is 0 here. Then there is 3. Then there is minus 2. Then there is minus 3. And then it is 4. Right. This way you sketch your given input signal. Once this is done, what is the next step we have to do? Now we have to identify what are the operations hidden in the signal. Right. So what are the operations hidden? So 3 multiplied by n, any constant multiplied with the time indicates it's a scaling operation. Right. So you are going to scale the signal. And there is a plus 2 done with the signal. It means that there is shifting. So there are 2 operations. There is no minus sign here to n. So no reversal. Right. So there are 2 operations which we need to do. Which are they? It is shifting and it is scaling. So according to the rules, we have to do shifting first. So we are going to shift the signal. By what amount? By a factor of 2. So what would be the name of the signal? So I will be calling the signal as S of n plus 2. So this is what we will be obtaining, S of n plus 2. So in which direction is the signal going to shift? It's an advanced signal. It's a plus 2. So signal is advanced. Advanced signal shift to the left hand side, right? Advanced signal shift to the left hand side, right? So how do we start shifting the signal? First of all, understand that you're going to shift the signal to left hand side by what amount? By an amount of 2. The shifting is by amount of 2. So look at the starting instant of your signal. Here the signal starts at 1. So signal 1 shifted 2 units to the left, where it will appear. So you just shift this signal 2 units to the left. So it starts at -2, right? It starts at -2. So it's the first sample we will be shifting to the left hand side by 2 units, and we will draw this signal at -2. So at -2 we will draw the first signal whose magnitude is 1. So I have drawn the signal here. Now this sample, right, shifted 2 units, definitely will be at -1, right? So just go on moving the position 2 units, right? So if you move it 2 units, first it will appear at 0, then it will appear at -1. So this sample appears at -1, no change in the magnitude. Magnitude of the signal during shifting doesn't change, right? So go on placing the signals 2 units to the left hand side. Simpler way would be, look at the end. What is the end? End sample is at 7. So this particular sample, when shifted by 2 units, is going to appear at 5. So you understand that you are going to terminate at 5, right? The sample begins at -2 and is going to end at 5. So simply go on sketching your signal now, one after other. So first sample is at -2, shifted by 2 units, it appeared at -2, plus 1 appeared at -1. This particular sample follows, so at 0 the magnitude is -1, then at 0 it is -1, then there is 0, then there is 3. I'll draw the next sample at this position, then -2. Simply go on drawing the samples one after the other. That gives you your shifted signal. Then there is -3, and then there is 4. So you could see automatically signal, the last sample automatically appears at 5. So seventh sample when shifted by 2 units is going to appear at 5, and here is where we obtained it. Right. So if you just mark the starting and ending instants and go on drawing your samples, you will get your shifted signals, right? Now what you do is you put the magnitudes of the signal, right? So the first magnitude was 1. So I'll put the magnitude here. The magnitude is 1. Then the magnitude was 3. Here the magnitude is 3. Then it is -1. Then it was a 0. Then a 3, -2, -3, and there was 4. So this is the way we obtain the shifted signal. Now what is the next we have to do? We have obtained one operation, S of n plus 2. Now we have to do the second operation, which is scaling. We are now going to scale this signal by a factor of 3, right? Here the scaling factor A is 3. A is greater than 1 indicates it's a signal compression. So we are going to compress the shifted signal. So scaling by a factor of 3. So multiply 3 to n. So what is the new signal name? So after I do this operation, the name of the signal will be S of 3n plus 2. So we are going to scale the shifted signal, right? So the name of the signal is S of 3n plus 2. I am going to scale this shifted signal, right? So it's a compression. How we perform compression? We perform compression by dividing the base by the scaling factor. So scaling is by a factor of 3. So let us start to divide the base by 3, obtain the new base and plot the signals at those new base. Right? So sample at -2, signal starts at -2. So -2 divided by 3, it's a non-integer value. -2 divided by 3 is a non-integer value. So as you recall earlier, non-integer samples are discarded. So we discard this sample because we plot the signals only at integer values. N, the base n of a discrete signal, takes only integer values. So minus 2 by 3 turns out to be around minus 0.66. So minus 0.66 is a non-integer value. We discard it. We don't plot any non-integer base. Right? So this sample gets discarded in the process of scaling. What happens to the sample at minus 1? Minus 1 by 3 is again a non-integer value. So this sample also is lost, does not appear after scaling. Let's move to the third sample, 0. So 0 divided by 3, it is 0. So no change for the sample at 0. Sample at 0 appears at 0. So let us draw the sample at 0, whose magnitude is, what is the magnitude of the sample? It is minus 1. So let us draw minus 1 at 0. Right? Let us move to the next now. At 0, at 1, there is no sample. At 2, where does this sample appear now? So 2 by 3, again a non-integer value. Right? So this sample also gets discarded. Right? This was 0 already, so there is nothing to be discussed here. 2 by 3, when I talk about this sample, 2 by 3, after I scale, it is going to appear at 2 by 3. Right? So 2 by 3 means it is non-integer, I discard this. So this sample is also lost during scaling operation. Let's move to the next sample at 3. So 3 by 3 divided by 3. So this sample, where is it going to appear? It appears at 1. The division results in integer value. It is 1. So this particular sample, after I scale, is going to appear at 1 with magnitude minus 2. So let us sketch the signal at 1, whose magnitude is minus 2. Right? So this sample is now appearing at 1. Next, we'll move to the next sample, 4 by 3. It's a non-integer, discarded. This sample is discarded, not considered. 5 by 3, again it is non-integer, it is discarded. So after you have done the scaling, how many samples did you obtain? We obtained only 2 samples. Right? You can put the magnitude of the samples here. Here the sample magnitude was minus 1 and here the sample magnitude was minus 2. Right? So these are the samples after we perform the scaling. All the remaining samples are lost as they appear at non-integer values. So let us move to the third step now. Problem says that you need to multiply this signal S of 2 plus 3n, here which we have obtained, S of 2 plus 3n is now multiplied with impulse, but it's a shifted impulse. So let us first of all draw impulse. So how is our impulse? We have just seen it's a standard signal which exists only at 0 with magnitude 1. So this is my impulse signal. Everywhere else it is 0, right? So impulse signal exists only at 0. Right? Let us name the signal. This is our delta n. Right? But the problem says that we need to shift it. We need to obtain the shifted signal of this. So let us shift this signal. So we'll name the signal as delta n minus 1. So we are going to shift it by 1 unit to the left hand side. Right? It's a delayed signal. So 1 unit to the left hand side. The signal now after shifting appears at 2 signals now. We have to multiply the signal that we have obtained, S of 3n plus 2, with the shifted impulse. The shifted impulse is now at 1. So what is the resultant multiplication? There is no sample at 0 in the shifted impulse, right? So 0, the 0th instant multiplied with 0th instant. Here the magnitude is minus 1, here magnitude is 0. So resultant magnitude will be 0. So at 0, there is no sample. What happens at 1? This impulse is shifted, is now available at 1. So both the signals exist. Multiply their magnitudes. So minus 2 into 1. So what is the resultant magnitude of the signal? The resultant magnitude of the signal at 1 is minus 2. So we'll now draw the resultant signal here. So resultant signal at minus 2 is minus, at plus 2 is minus 2, right? So we'll draw the resultant signal here. So I have drawn the signal here, right? What is the magnitude of the signal? The magnitude of the signal is minus 2. You can put the magnitude of the signal. The signal is having magnitude minus 2, right? So this is the answer of the resultant signal which has been asked. The question was, you can name the signal properly. So finally our resultant signal is S of 3n plus 2 multiplied with the shifted impulse, and the sample is only one sample at 2 whose magnitude is minus 2. Rest everywhere else the signal is 0. So this is how you obtain the sketch of the given problem doing certain operations, signal transformations on it. Let us look at one more problem. What has been asked to you here? You have been asked to obtain a CT signal xt, right? The problem says you obtain a CT signal xt whose equation is 2t minus 2 for minus 1 to 2. Your signal exists from minus 1 to 2. Everywhere else it is 0. So understand the given problem. You have been given a mathematical representation of the signal xt, and the signal exists for what time instance? From minus 1 to 2. So very first thing that comes is you mark your signal xt with the time extending only from the region from minus 1 to 2. So signal exists only from minus 1 to 2. Everywhere else the signal is 0, right? So we'll now plot the signal for these time instants. So how do we plot the signal? Put the values of t, right? Put the values of t. So let us start with t as minus 1. So when I put t as minus 1, what is the resultant magnitude? 2 into minus 1 is minus 2 minus 2. So resultant magnitude is minus 4. So I'll repeat. Yes, somebody has turned on the mic. Please turn off the mic. I request you to turn off the mic. Somebody has turned on the mic. It is very essential that you put your mic off. It disturbs everybody. Okay, so I'll repeat once again. We are going to put the t value here. So at t minus 1, right? What is the resultant magnitude of the signal? You have to find the magnitudes. To plot the signal, you need to get the magnitudes. You know that the signal exists from minus 1 to 2. But what to draw at minus 1 is the magnitude of the signal. So how do we calculate the magnitude? So put your t values in the equation. So with t minus 1, what is the magnitude here? 2 into minus 1 becomes minus 2. Minus 2 minus 2 is minus 4. So the resultant signal at minus 1 is minus 4. So if you want, you can simply mark the points first. Right? So here, I understand that here is my magnitude minus 4. So we'll simply mark the points first. Then see, let us calculate the magnitude at 0. Next time instant, t is 0. When I put t as 0 here, what is the magnitude? So 2 into 0 is 0. 0 minus 2 is minus 2. So at 0, I expect the signal to have a magnitude of minus 2. Right? At 1, for the next time instant t1, what is the magnitude? When I put t as 1 here, so 2 into minus 2. So resultant magnitude is 0. So at t0, the magnitude is t1, the magnitude is 0. When I put t as 1, I get a magnitude 0. So at 1, the magnitude is 0. The last time instant, when t takes a value 2, if I put it here, 2 into 2 is 4, 4 minus 2 is 2. So at 2, I expect the magnitude to be plus 2. So you have got your points now. So at minus 1 it is 4, minus 4. At 0 it is minus 2. At 1 it is 0. And at 2, right, at minus 1 it is minus 4, at 0 it is minus 2, at 1 it is 0, and at 2 it is 2. Once you know these points, now what you have to do is simply join the points, right? So if we join the points, we get the resultant signal, right? So at 0 it is -2, at 1 it is 0, and at 2 the signal reaches a magnitude of +2. Right? And then everywhere else it is 0, so I have to bring the signal to 0. Here also signal comes to 0. Why? Because everywhere else, they have said here, everywhere else the signal is 0. So outside this range, greater than 2 and less than -1, everywhere else it is 0. So you need to bring these signals to 0. Right? So this is your given signal. So if you can put the magnitudes of these signals here. So magnitude here is -4. Here it is -2. At 1 it is 0. At +2 it is 2. Right? So these are the magnitudes of your signal. Right? So at +2 it is +2. Right? So now we understood what is your given signal. Once the signal is sketched, now you look at what is your problem task. So your problem task says you have to first of all find x of -t -1. So identify the operations. So there are two operations here. One is shifting t -1 and another is reversal. Minus t hai, it means that there is a reversal. Right? So we'll first of all perform shifting of this signal. So we'll shift this signal. Right? So we'll shift this signal by 1 unit to the left. The name of the signal will be x of t -1. So this particular signal shifted by 1 unit to the right hand side will give me my desired signal x of t -1. It's a delayed signal. So entire signal, without changing the shape of the signal, you need to shift it to the right hand side. So this particular starting point of the signal is at -1. Shifted by 1 unit means it starts at 0. So first of all you identify where the signal starts and where it ends and simply join those points. So now we understand that the new starting instant of the signal is going to be 0. What is the ending instant of the signal? Look at the end point. So this particular point 2 shifted by 1 unit will appear at 3. So now I understood that when this signal is shifted by 1 unit to the right hand side, will start at 0 and end at 3. Right? Will start at 0 and end at 3. So once I mark the starting and the ending instant, simply re-sketch your signal for these new time instants. That is as simple as that. So if we simply follow that rule, we will not make any mistakes. So at 0, I will start sketching the signal. Signal starts with a magnitude of -4. Then it reaches a magnitude of -2. Then it reaches a magnitude of 0. And then it reaches a magnitude of +2. Right? And then we need to bring the signal to 0. So this is your new shifted signal, shifted by 1 unit to the right, which we call as delayed signal x of t -1. Right? How simplified way we did is identified the new starting point, identified the new ending point, and simply went on sketching the magnitudes of the signal within this time instance. Right? And we obtain the shifted signal. Right? If you want, you can put it is essential to put the magnitudes. Right? So here the magnitude is -4. At 1 the magnitude is -2. At 2 it is 0. And at 3 it is 2. So these are the magnitudes of your signal. Now what is the next thing we need to perform? We have performed shifting. Now we need to perform reversal. We have to reverse this shifted signal. Right? So when I reverse, what is the name of the signal? Append a minus sign to your t, that becomes reversal. So the name of the signal is x of -t -1. So we are going to perform reversal of this particular signal. How to do reversal? So simply negate your base and reflect it on the other side. So signal at 0 remains at 0. So there is no change for the signal at 0. Signal at 0 remains at 0. So this particular sample of magnitude, this particular signal changing from 0 to -4 will reappear as it is at 0, because there is no reflection to the point at 0. So we'll start to sketch from 0. Right? So at 0 the magnitude is -4. Correct? Here we reach to a magnitude of -4. Now what happens next? At plus 1, the magnitude is minus 2. This should reflect on the other side. So whatever is at plus 1 will appear at minus 1. So at minus 1, the magnitude is minus 2. Right? So whatever is here should appear on the other side. So at plus 1 here, the magnitude is minus 2. At minus 1, you expect the magnitude to be minus 2. No change in the magnitude. What changes is the time. Right? So at minus 1, magnitude is minus 2. At 2, it is 0. Reflect the same on the other side. So at 2, minus 2, it should be 0. Right? So whatever is at plus 2 should appear at minus 2. So at plus 2, it is 0. At minus 2, it should be 0. So at minus 2, we obtain the magnitude. So at minus 2, the signal is 0. So this is how the signal extends and reaches to minus 2. What happens now? The next time instant is 3. So at 3, the magnitude should be 2. So at minus 3, the magnitude should be 2. So at minus 3, the magnitude should be 2. That is your reverse signal. Right? So I'll simply extend it. Right? So at minus 3, the magnitude is minus 2. Now tend it to 0. Right? This is your time reversed signal. Right? So we have reversed it. Whatever are the magnitudes at positive instants, put those magnitudes on the negative instants. Right? So at plus 3, it was 2. At minus 3, it is 2. At plus 2, it was 0. At minus 2, it is 0. At plus 1, it is minus 2. At minus 1, it is minus 2. At 0, it is minus 4. 0, it is minus 4. So when you join the points, you get your time reverse signal. So this is your time reverse signal. Now what is the next task we have been told to find is multiply this signal by a ramp signal. Right? So we'll be multiplying this particular signal finally with a ramp. So ramp is a standard signal. So let us first sketch the ramp signal. So ramp signal is a linear signal which increases with respect to time as time increases. So at 0 it is 0, correct? At 1 it will be 1. Right? How would you draw the signal? At 0 it is 0, at 1 it is 1, at 2 it is 2 and so on. So your ramp signal simply goes on increasing with respect to time, correct? So you see a ramp signal is simply increasing with respect to time. Now if you multiply your x of minus t minus 1 with the ramp signal, right? What is the final result? What is the final multiplication result? So if you observe, this signal is entirely 0, right? This ramp signal is entirely 0 on the left hand side. It exists only on the right hand side. Whereas the signal that we are going to multiply it with exists only on the left hand side. The signal is absent on the right hand side. So if you multiply such a signal, here the signal magnitude is entirely 0. 0 into any magnitude would be 0. So this entire signal will turn out to be 0 in the resultant sketch. So if I'm going to sketch this product, the product on the left hand side will be entirely 0. What happened to the right hand side? Right hand side, our signal is 0, ramp exists. But the signal with which we are going to multiply ramp is 0. Right? So 0 into the magnitude of the ramp will be 0. So finally the entire magnitude of the signal is 0. Right? So there is nothing here. The signal is entirely 0. Right? It's a 0. Product of these two signals is 0. Right? So how would you finally write your answer? What was expected to you is multiply x of minus t minus 1 with the ramp signal, right? This results into 0 and your final product, even though it is 0, you are expected to sketch it and show your signals, right? So we could show here that the resultant signal x of minus t minus 1 with the ramp signal rt is 0. So there is 0 here. There is nothing.